Welcome to Algebra 2. I'm Dr. Murray Siegel. I'm a mathematics teacher at Marietta High School in Marietta, Georgia, and in fact I teach Algebra 2. And the purpose of this series is to help those of you who are having difficulties in Algebra 2 and also to help those of you who want to get a head start on Algebra 2. Algebra 2 turns out to be a very, very important mathematics course, even for those of you who are not planning careers in mathematics or science or engineering. And obviously, for those of you who are planning careers in those fields, Algebra 2 can be a unique experience because hopefully you'll learn enough to help you get into those career areas. What are we going to do in this series? Well, in this series, we are going to look at 29 other lessons. This is just an introductory lesson. 29 lessons that hopefully will cover some of the most important areas in Algebra 2. And what I will do in those lessons is to introduce items or review items, if you've seen them in Algebra 1 before, explain things, in many cases take great lengths to explain the reason for certain formulas or methods, to develop step-by-step ways in which we solve problems in Algebra 2, give you examples of applications of why you need to know Algebra 2. And later on in this lesson, we'll talk about how you can use these tapes to maximize the chance of success for you in the Algebra 2 course. But the first question we have is, what do we need Algebra 2 for? We've had Algebra 1. Well, Algebra 1 is sort of an introductory, a baseline in algebra. Algebra 2 really is the first course you take that is the anchor for everything you'll need in high school and college mathematics. It's also very practical, and many of the things we study in Algebra 2 are quite useful. For example, when they launch a rocket or they launch a shuttle, how do they know, when to turn the engines off, how high it's going to go? When we put men on the moon, how were they able to get across 240,000 miles of space and land at a precise location? They used formulas, they used equations, they used something we'll talk about in a little bit called models. They used algebra. They used many of the things we'll talk about in Algebra 2. If you ever have the opportunity to visit a plant that has a production line, especially something producing things you like, let's say like soda pop or potato chips, you'll notice that they are producing thousands and thousands and thousands of items of product every hour. And yet every one of those bags of potato chips has very close to the same amount of saltiness. And every one of those thousands and thousands of cans or bottles of soft drink has very close to the same amount of fizz. How do they do that? How do they control that quality? Well, some of the things they do involve areas we'll cover in Algebra 2. We'll cover in these tapes. New York Stock Exchange or any other stock exchange in this country or throughout the world, people buy and sell stocks, and many of these purchases or sales are made based on the recommendations of experts. How do these experts know when to buy or sell? Many of them use algebraic techniques. They use economic models, something we'll talk a little bit more about later on. I assume if you're taking this course, you're seriously considering going to college. Before you can get admitted to most colleges, you need to take the SAT or the ACT, admissions tests. The college will make a prediction based on your SAT or ACT score on how well you will do in your freshman year. They are really using algebra. We've all heard about the loss of acreage in the rainforests of this world and how that's affecting our weather, how it's affecting the amount of carbon dioxide in the air, and eventually will affect our own lifestyle. How do they know about this? How do they know how to make these predictions? How can they tell us what's going to be happening 10, 50, 100 years from now? Well, as you might have guessed, they're using algebra. They're using many of the techniques that we'll be introducing in Algebra 2 in this tape. Even those of us who are into sports, and I'm a big football fan. I really also like baseball quite a bit, but football is an excellent example. In fact, I will give you some examples later on. But for example, when they are predicting what a team might do, when they are looking at tendencies, and as we'll see later on, when teams are scouting college players to try to figure out who is the best player for their needs. In many cases, the analytical methods being used are based on things we will discuss in this tape series. So, what is this all about? Well, let's go to the easel and write a couple of words on there that hopefully will explain some things to us. The first word is function. In a number of the first couple of lessons, I will use this word quite a bit. And then we'll have a whole lesson talking about functions. Okay? Another important word is model. And we're not talking about a model that wears clothing and shows everybody the new styles, or even something like a model airplane. We're talking about an algebraic model, where scientists can model the flight of a rocket, where economists can model the economy and interest rates, unemployment, and the building of houses, where sociologists can model the growth of population in a particular area and the growth of income among certain people. And these models use equations. And in fact, much of what we are going to discuss in this course is based around equations. So let's write the word equation. We're going to go back and discuss solving equations. Equations you solved in Algebra 1. And then based on that, we're going to solve equations you have not yet seen unless you're already well into an Algebra 2 course. The other word, system. Because in effect, we'll see that in many cases, one equation is not enough to describe something. We'll need a system of two or more equations to build our model. And ultimately, what we're going to do is to solve systems of equations by solving individual equations to come up with values that are important. We're also going to learn about sketching graphs, because we'll see that graphs of these equations, graphs of these systems, will give us a picture of what we're talking about. And we'll spend quite a lot of time in the lessons towards the end of the series looking at types of equations perhaps you haven't seen, how to solve those kind of equations, how to sketch graphs of those equations. Let's look at the first visual, which shows us types of equations that we will look at in this series. The first is linear. These are equations you've definitely seen in Algebra 1. Next, we'll look at quadratic. These are equations that have an x squared in them, and probably you've seen some of these in your Algebra 1 course. Then we'll look at more general polynomial equations. Following that, we'll look at rational equations. This doesn't mean they act in a rational manner. It means the equations involve fractions, where the numerator and denominator of those fractions are polynomials, are algebraic terms. Then we'll look at exponential functions and their applications. And then, finally, logarithmic functions. And you may not even be familiar with what a logarithm is. If you're not, this will be an introduction to logarithms for you. Finally, in our very last lesson, we'll just touch upon something called the trigonometric function. We'll look at trigonometry. So this is sort of where we're going. Now, to give you a picture, and I really need a picture of what we're going to do, let's look at the next visual. It looks like a piece of graph paper with the measles. We've got a set of axes, horizontal or x-axis, vertical or y-axis, and a bunch of dots or points. This is called a scatter diagram. This is how we collect data to look for a relationship, for example, between your SAT or ACT scores and your success in college, or perhaps between how much a community spends on fighting crime and the crime rate, or any other relationship, how much we pay our employees and their productivity, how many hours you work and how well you work at the end of that period of time. Whatever we're trying to build a relationship on, we can use a scatter diagram. And then, as we see in the next visual, we might draw a line as an approximation to this relationship, as a kind of an average, just as we average grades on tests and come up with one number. We average the picture on this graph, all these points, by drawing a line that best approximates. And of course, one of the things we'll look at is finding the equation of that line. Once we have an equation of that line, we'd be able to predict, given your SAT or ACT score, how well you'll do as a freshman in college. Given the amount your town or county spends on police and other crime-fighting areas, what we can expect the rate of crime to be. And any other thing that might interest you where there's a relationship between two measurements. Sometimes in our modeling, we look at two different equations, two different lines, and we're interested in where they meet. As seen in the next visual, we're looking for the intersection to solve this system of equations. This could be the intersection of two lines, one representing the cost of producing and selling a product, the other representing how much money we make when we sell that product. And the intersection point, as we'll see later on, will be the break-even point, where we are no longer losing money, and as we sell more product thereafter, we'll be making a profit. Very, very important if you're in business. Okay, now, let us talk about how you can best use this series. And after we do that, we'll talk about precisely where Algebra 2 fits in, and then I'll go through and sort of just talk about what you can see ahead, what the lessons are. And indeed, if you're having a problem in a particular lesson, you may want to jump ahead to that specific lesson. But I've sort of designed the sequencing to meet the needs so that when you're in lesson 15, for example, probably you're going to be calling upon things we've learned in previous lessons. We build as we go along. Okay, the next visual shows you what I consider the best way to use this tape series. The first thing you need to do is watch the tape. Obviously, turning the TV on, turning the VCR on, running the tape, and then walking into your bedroom and calling your friend and speaking for the telephone is not going to help you. I mean, this tape is not a cure-all. It doesn't just turn it on, everything gets wonderful. You must watch the tape. And in watching the tape, unlike watching your teacher in class, you can stop the tape. You can stop the tape, rewind it, and review. So if I say something that isn't very clear, you may say, wait a second, I didn't understand that. And in class, you'd raise your hand and say, you know, what the teacher's name is, hey, could you go back and explain that again? Here, obviously, this is not an interactive television. Maybe someday we'll have that. So if you raise your hand in your living room or wherever you're watching this, I cannot see you. So what you can do, though, is stop the tape, rewind it back to the point where I began to talk about the thing you don't understand, and play it again. And perhaps by watching it again and looking carefully at what I'm saying, you'll be able to understand. Now, there are some points in this tape where I say, look, this stuff here is kind of difficult. I'm showing it to you because I want you to understand where we got this equation or this formula or this method from. But it's not necessary if you understand it. So at that point, if you didn't understand the process to get to this magic equation or formula, that's okay. If you want to rewind it, that's fine. You don't have to. But it's important for me to know that you've seen from whence we got whatever we're using. The formula itself is something you need to know and be able to use. Now, also, you need to work the problems. In fact, in many places along the various lessons, I will say, all right, here's a problem. After I get through talking, stop the tape and work the problem yourself, and then come back and we'll work the answer. It's very, very, very important. It's vital for you to do that. If you just sit back and watch me do it, hey, I can get an A in Algebra 2, especially if I make up the test, because I'll know the answers. But the fact is that this is for you, not for me. So therefore, in fact, even if I don't say that, if I do a problem, you may want to copy the problem down, stop the tape, rewind the tape, then work the problem. At other times, you may want to write these problems down without the answers, and later that day, or the next day, perhaps, work the problem. Go back to that point in the tape, play the solution back, and make sure you know what you're doing. The next item on this list is to find similar problems in your text. If you are already taking an Algebra 2 course, you have the book. And therefore, for example, if we're talking about solving quadratic equations, go into your book, look in the index or in the table of contents and find the chapter on quadratic equations. Look at the back of various sections and find problems that look just like the ones we're doing on this tape. Most textbooks have like the answers to odd number problems in the back of the book. Be sure to work the problems that you have answers for. Work as many as you can until you get totally bored, hopefully getting the right answer. If you get wrong answers, go back and again review the tape. If for some reason you stop watching the tapes for a while, you may need to go back and look at some things again, because in many of the lessons we recall items learned in previous lessons. That's the great thing about VCR tapes, is that you can watch these over and over again, go back and just review. Something you cannot do. The teacher reviews when he or she wants. Before the test, before the final exam, they'll conduct a review. They may answer questions in class. But as a teacher myself, I know that if I'm teaching in Chapter 4, and I have students raise their hand asking questions about Chapter 2, I'll probably say, come by and see me before school or after school. We don't have time in class to do that. The beauty of these tapes is the time is yours. You can rewind and look at any particular lesson you'd like. So again, watch the tape, stop the tape when you don't understand something, rewind, replay the tape to ensure you understand it, work all the problems that I do, be sure you get them right, and use your textbook, if you have one, to find similar problems to ensure that you have mastered each of these processes, each of these solution or graphing methods. Okay, where does Algebra 2 fit in? The next visual shows us that. There's Algebra 2, leading its way to college algebra. Now, college algebra can be taken in high school. In some schools, it's called senior mathematics. In some schools, it's called advanced algebra and trigonometry. In some schools, it's called functions, statistics, and trigonometry. Some course generally designed for seniors who are going to college. And it's a good course to have, because once you take that course, you can skip over the college algebra course at the college level in many cases. Again, what you learn in Algebra 2 is a key to that. Solving and sketching those equations, learning about exponential and logarithmic functions is vital for success in college algebra. From college algebra, you may lead to one of two areas. Some people actually will take both areas. Those of you who will be going to college and majoring in, again, engineering, the sciences, mathematics, computers, will probably go through the calculus sequence, taking pre-calculus, which calls upon many of the skills we learn in Algebra 2, and eventually taking calculus. In fact, in a number of lessons throughout this tape course, I will refer to things that we'll do in calculus. Those things we'll do in Algebra 2 that will help us in calculus, that will expand upon in calculus. Many of you who are going into the social sciences, economics, into the business world, sociology, psychology, will be taking statistics courses. Some of them may be mathematics statistics courses, others will be within your discipline. For example, a quantitative methods course in the business school, experimental psychology in the psychology department, sociological research in the Department of Sociology. These are all courses heavily based on statistics. Statistics, in many cases, applies the notion of function and model that we will use in this series. And many of the problems that I do will be problems that are natural to the statistics course. So I think you'll see that in either the calculus path or the statistics path, Algebra 2 is absolutely vital. And in some of your cases, especially some of you going to very good colleges of business administration, you will do both. You will take a calculus course, you will take at least one statistics course, and Algebra 2 and the skills therein will be vital for your success. Now, let's go ahead and take a look at the kinds of things we will be studying. And really all I'm going to do now is go through the outline and talk about the various lessons we'll do here and give you a flavor for what's going to happen. Lesson number 2 is polynomial arithmetic. I am going to relate the notion of polynomials to arithmetic just like you learned in elementary school. Lesson 3, we'll talk about factoring. Now, in factoring, you've seen this in Algebra 1, and some people do have problems with it. What I will attempt to do is show you a way to attack problems that involve factoring. Use a very rational method to find the complete factoring pattern for a particular situation. Okay. Then we're going to look at solving linear equations. Again, something you did quite a bit of in Algebra 1. We're going to look at how we solve and why we do what we do, and we'll lay the basis for many of the solutions to systems of equations that we'll tackle later on. That's Lesson 5. In Lesson 6, we'll bring in some statistics, the statistical concept of correlation, and use a statistical problem involving used cars and relating their value to the age of the car to look at slope and intercepts. Slopes and intercepts are things you discussed in Algebra 1. If you've taken geometry, you have discussed them there. We will look at it through the use of statistics to see the application and to sort of relate the notion of slope and intercepts to something quite meaningful rather than to the abstract nature of what you might have seen in your algebra class. Then we'll look in Lesson 7 at the equation of a line. Now, you've seen this again in Algebra 1. You've probably seen it if you've taken a geometry class the previous year. We will look very, very closely at various methods of finding the equation of a line. We'll look at parallel lines and perpendicular lines and their equations. Then, in Section 8, we'll look at graphing linear equations. Actually, given an equation, how to graph it. Again, looking at various methods, using plotting points, using the slope and intercepts, and even looking at what's called the point-slope method, which maybe is something you did not see in Algebra 1, which can be very interesting, especially when applied in the area of statistics. In Lesson number 9, we'll talk about graphs of linear inequalities. Again, inequalities turn out to be a very, very important thing, something we spent some time in Algebra 1, but in reality, in the real world, examples exist, many examples exist, where we use inequalities. That is, there are many solutions. It's not just that the answer is 2,000, is that the answer is 2,000 or less, or perhaps 2,000 or more. And I will give you some very specific examples on the use of inequalities. That's Lesson number 9. Then we come to Lesson number 10, which is solving systems of two linear equations. We'll use various methods to solve those systems. I will point out points in time when you need to use those methods, and also when you can't. I will also give you a very specific example of why we want to solve systems of equations. And then in Lesson 11, we'll find a fourth method called elimination, which will turn out to be probably the most useful. And the reason, as I explain in the lesson, we spent time in Lesson 10 looking at other methods, is that in many books, all the methods are discussed, and you may have a teacher who wants to see you solve using various methods. Also, you may find another method is more friendly in your hands than perhaps how I look at it, where I see that this method called elimination is the easiest method for me to use. Okay, then we'll come to Lesson 12, which will solve systems of three equations, an extension of Lesson 11, and also looking at systems of linear inequalities. And that, again, we'll see leads into something those of you who may be interested in pursuing a business degree will be something you'll tackle in quantitative methods courses at the college level. Then we'll talk about functions. I mentioned the word function earlier. In Lesson 13, we will discuss function. We'll look at non-mathematical examples to hopefully bring us in a focus as to what a function is, and we'll look at all aspects of a function, including the notion of the inverse function. And then we'll begin to look at the various types of functions. First, the quadratic function and the graphs of the quadratic function. Then, in Lesson 15, we'll start solving quadratic equations using, again, various methods. And then in lesson 16, we'll say, here's the method that always works. But again, we develop the other methods to give us a rationale for this quadratic formula, something that if you haven't already memorized, you will certainly memorize the quadratic formula. I will explain to you where it comes from. And again, it's one of those things where when you see it, you may say, gee whiz, I'm all confused. That's okay. At least you've seen its derivation. But you'll see how to use the quadratic formula to solve and even to help us graph quadratic equations. Lesson 17 covers imaginary numbers. If you don't know what an imaginary number is, it is not something that you see in your dreams. It is a type of number. In fact, it's the square root of a negative number. In the past, you may have said, well, that's no such thing. But well over 100 years ago, someone came along and said, we are going to give a symbol so we can always take a square of a negative number. And in fact, it turns out later on, as we'll see, some people use these imaginary numbers in solving real-world problems. Then in lesson 18, we'll look at inequalities that are quadratic or rational. And we'll solve those and talk about positive and negative numbers, something to really look forward to. In number 19, lesson 19, we will look at polynomial division, the one kind of arithmetic that we will not see in the lesson on polynomial arithmetic, because this is more advanced and will introduce the notion of synthetic division, something that is seen for the first time in an Algebra 2 class. I will again show you why it works and how it works, and we'll use it from then on. Then we'll look at what's called zeros of polynomials. We'll set polynomials equal to 0 and find values of x that will make the polynomial 0. Very, very important. As we'll see, we get into sketching of polynomials, because in many real-world situations, the actual model we'll use will be a polynomial model. It's a very simple model to use, and one of the things we need to know is, when is this model 0? And what does it look like? When is it increasing? When is it decreasing? What's happening over long periods of time if indeed what we're looking at is something that's a function of time? So lesson 21 will cover that in the sketching of polynomials. Then we'll sketch rational functions. Rational functions, again, are the ratio of two polynomials. And this is something you'll spend a good deal of time on later on in courses beyond Algebra 2. Then we'll look at square roots and cube roots, look at the equations involving square roots and cube roots, and the graphs of square root and cube root functions. That's lesson 23. In lesson 24, we'll look at exponential functions, something that's really important in the area of marketing and in the area of population. We see things rising exponentially. Also, we'll look at half-life, which is an exponential decay situation. Again, very important when dealing with radioactive materials. That's lesson 24. Lesson 25, logarithmic functions. And unless you've been in Algebra 2 for quite a while, you probably don't know what a logarithm is. We'll see what it is, we'll learn about it, and we'll learn how to solve logarithmic equations and how to graph logarithmic functions. Then in lesson 26, we'll learn all about matrices and determinants. And I suspect that most of you have not seen these at all, have no idea what I'm talking about, but we'll leave that to lesson 26 to introduce and show you really it's quite simple to work with these things. And then in lesson 27, we will use what we learned in 26, that is matrices and determinants, to solve systems of equations that appear difficult to solve in earlier lessons. In lesson 28, we'll discuss recursive functions. Again, something that will probably be fairly new to you that's quite useful, especially in the area of computers. And we'll relate recursive functions back to linear and quadratic functions and the solution of systems of equations. The last two lessons will definitely be something you probably haven't seen before: sequences and series, which is covered in lesson 29, and an introduction to trigonometry in lesson 30. So you could see, if you've even taken a few months of Algebra 2, some of the things we'll discuss will be review or extensions of things you've learned. Some will be quite new. My hope is that if you watch the tapes, do the work, follow what I'm trying to teach you, that you'll not only be able to do many things, but also understand where the methods came from, how we derive what we're using, and most importantly, that indeed what we do in Algebra 2 is quite useful in the real world, no matter what career patterns you may choose for yourself. So get your mind ready, have a sharpened pencil, you may need a calculator handy, and I'll be looking forward to seeing you on the next 29 lessons. Welcome to Algebra 2.